can be used to compute a speed based on travel time or measure distance based on speed. The spacing between the marks on the tachymeter dial are therefore proportional to 1 over t, where t is the elapsed time. I guess so. Weird.
We're not finished?
No, we are not, Fuang. We have one lesson left in waves, which I'll at least start now.
I don't know.
Why we have to study? Why?
Yes. Yes.
But people in the past, they didn't have to study.
My father
Indeed. Stationary waves. Write that down, please.
Why we not study this tomorrow?
Because we still have 20 minutes left.
20 minutes?
Yes, 20.
Can't do anything.
Maybe you can't do anything. 20 minutes of stationary waves. You got that title?
Yes.
Yep. Right. One.
Yeah.
A standing wave, also called a stationary wave, is a wave that oscillates in one constant position. It can arise in a stationary medium as a result of interference between two waves traveling in opposite directions. What the heck does that mean? I'll draw it here. So what you have here is a stationary wave. This string is vibrating. But when the wave moves to the right and hits the end of the string and moves left, the timing is so that the wave doesn't appear to move, but instead appears to move in a sort of up-down position like this with my hand. What's happening basically is the wave is switching between this and then quickly becomes this. It's like it's flipping upside down. This happens so quickly that when we look at it with our eyes, it looks like this shape. So basically the wave is flipping up, down like this. It's not moving anywhere, it's just turning upside down.
So like it comes to the end and then it comes back?
Yeah, and when it comes back, it actually flips upside down. This is the definition, please write it down. Yeah. Got it? You wrote the whole definition down. All right. They're amazed.
What does it mean it can arise in a stationary medium as well as that?
The string here, this string medium is kind of stuck between the two ends of the machine. It's stationary in the sense that it's not moving through the air, not really propagating anywhere. You got this, Omar? Yes. Continue?
No.
No.
It's okay, Yusuf.
Hang in there, Yusuf. Hang in there. You only have 13 more weeks of Faisal and then you're free. And how many weeks are in semester 2? It's about 12 weeks, isn't it? Isn't it something like this? I don't know. And you're and we're nearly finished semester 1, so. Huh? Maybe. All right.
And then I can't meet you anymore.
Yeah.
No.
Oh, where are you going? Cork?
Oh.
Oh, that's at least 2 or 3 hours away, isn't it?
But maybe I will be
Not far
in
enough.
the IT. But maybe I will be in the IT.
I know.
The IT is bad for farmers.
Yeah. No, Cork.
Cork is not the best, maybe UK is better.
True. Or even further, perhaps, Eastern Europe, I believe.
Vietnam is really good for farmers.
Yes. It's interesting that way. Okay, you got this? Yeah.
You get to speak in Vietnamese again.
Yeah. I know you don't like English. You don't like English or that English? Which was it? It's okay.
I like the English.
Do you?
Yeah, I
That's-
want to marry the English.
You do?
But I don't like English.
This has got you. Yeah, see, you don't like English, but you want to marry someone from England. It's, I don't know.
He is not the English.
Yeah.
No, he's not.
Yeah, she knows that.
Yeah. And
Yeah.
it's England.
Yeah, she knows that. Yeah. You think she made a mistake when she says she likes the English because you thought she was talking about me. All right. Now, on the diagram we have places called nodes and antinodes. So a node is the part where it has minimum amplitude. So you see this point here and this point here. It looks like the wave doesn't move there. But here in the middle, and here, this is where the most vibration happens. So these ones are called nodes. It's where there's minimum vibration. And antinodes, maximum. So here, node. In blue, on the top and bottom are the antinodes. Please write and draw this. Oh, Faisal, I don't need 2 alarms, for goodness sake. Oh, which actually the alarm reminds me of something. In the last class we did constructive and destructive interference. Remember that? One application of destructive interference is in a factory. The factory makes a lot of sound, of course. Did I tell you this? No, I don't think I did. No, I didn't.
He said factory.
Yeah, I said I would explain it. So, in the factory, the machines make a lot of sound. And then you have speakers that produce a wave so that when it combines with the sound wave from the machine, the waves destruct. They cancel. Now, of course, it is not possible to perfectly cancel it. The reason being, for the same reason I gave you earlier, the wave is not a nice smooth wave, it's jagged. So trying to produce a wave that perfectly is the upside down of that wave, the opposite of it, it's not possible. So you'll still be left with a little jagged wave, but it will greatly reduce the sound. Okay. Have you drawn this? You drew this, Omar? Oh, Omar, come on, draw it, please. I need the diagram too in your notebook. It's a wave.
Give me, I'll draw it.
No, don't.
I'm serious.
Don't, please. He has to learn. He has to learn to be independent.
What? Independent.
You know this word?
Independent. I'm a stronger independent.
Independent what? Male.
Independent woman.
Good.
You can't be a strong girl and independent woman in the same time.
No. Presently she is a strong, independent girl, but on the 9th of April, 9th of April?
Yeah.
Strong, independent woman.
Woman.
But until then, strong, independent girl.
So we're all men.
Some people would question this, perhaps.
No, like Dr. Lorraine was like, you're not men until you're 25.
She said this to you. Some of you, I
Not
don't
to
think,
me.
will ever be men at 25 years.
Flash wasn't
She's nearly there.
Who's the eldest?
Is it?
You're not the eldest at 20, are you?
Yes.
In our class.
In this group right now.
Yeah.
No, another is 21 there.
Yeah, now there's 21.
Ah, so everyone here is between 17
And
and
he wants
20.
to do an English course next year again.
This year, I think.
Well, this calendar year, yeah.
Yeah.
Ah, these are his plans, is it?
Is that why he's not coming?
Well, he must have some plan because he's not here. So if he's already decided I'm just going to do an English course, then maybe he feels it's not necessary. But he still comes to some classes, so I don't know.
He comes to English classes on the other.
You've noticed this?
Yes.
Okay. Well, then maybe it sounds like he has a plan. Okay.
Like an English course for the third time.
Because he told me he doesn't understand anything without his being taught. Like he doesn't understand.
But then an English course is like 2,000 euros. This is 10 times
Yeah.
more.
Yeah. Oh well.
And if he did attend, he would benefit way more.
Apparently attendance is useful for understanding. Yeah. Okay.
No, attending those classes that he's missing is also English practice.
Yes, it is. Yes. Okay.
Are you packing your bags?
Are you going to put that at the end of the umbrella and carry it over your shoulder? Homeless style. What? Never mind. If the distance between the nodes or between the antinodes is known, then it's very simple to know the wavelength. So let's try and figure out a formula here. Let's imagine I know the distance between, let's say, the nodes. Yeah, we'll call this d. Then the wavelength would be twice this. So it's just twice the distance between the nodes or the antinodes is the wavelength of the wave. I think that's worth writing down. And I already drew it. You have this? Continue? No. Whoops.
Can you show the picture of the ascending waves of the thingy that's...
In the previous slide or what I drew?
No, the previous slide. No.
Yes?
Yeah. What's this machine called?
Haven't a clue. Standing wave generator.
No.
Oh, really? You don't believe me?
I
don't.
believe.
I don't know.
Allah.
I haven't a clue because I don't necessarily think it's any type of special machine. You really just need something that vibrates.
It's in these shops, like the...
Oh, it's in
the weird one.
It's the standing wave generator shop.
No.
No. There are like these really weird shops in Hawaii.
Oh, no, not those.
Are you talking about hemp stores or something?
No. It has like all these like weird lighting light things and mats and all that.
Dude.
Oh.
I don't need to know about your personal life.
These weren't the shops I was talking about.
That's what it's called. That's what the machine called.
Oh.
All right.
Yes.
You retract your statement, do you? Yeah, okay. One day you need to tell me what you wrote, but not today.
You want today?
You said, you kind of said it.
It's
Okay.
very simple.
All right, okay. Okay.
What does this thing do? The thingy that moves.
Vibrates. Yeah.
Keep on going further.
Give it make it a noun.
I see. All right.
Our goes different. One side only is vibrate, and then we This would be tied to something.
Yes.
I hope so. This would only be vibrating.
Yeah, okay. We're back to being boys, I see. Maybe men at 35, perhaps. Yeah. Okay, so next now, fundamental and harmonic. If a string is held at both ends, forcing zero movement at the ends become zeros or nodes of the waves. The length of the string then becomes a measure of which the waves the string will entertain. The longest wavelength is the fundamental. So in other words, if you have a string, there's many ways you can make a wave on a string. Picture like a guitar string. One way it could vibrate is like this. The string could vibrate up and down this way. But of course another way it could vibrate is maybe like this. But in each case we have a different wavelength. The biggest wave we can make is when it vibrates like this, because the wavelength would be from here and actually kind of like to here. Although the wave doesn't obviously continue, it's like the wave is like this. So if this distance here is L, what would be the wavelength here? 2L, yeah. This is the biggest wave you can make with the piece of string. Of course you can make the wave extremely small. If you picture a string that's like this, the wavelength here is much, much smaller because you have many little waves. So the biggest wave we can make is if we have something like this. Can we make it any bigger? No, because if we did, we'd have a problem. Like this. This is now no longer attached to the musical instrument. So the biggest wave we can make is called the fundamental wave. Usually this comes up in context of musical instruments, but not always. Half a wavelength of the fundamental fits on the string. So we can get half the wave in. Now I don't need you to write this down right now because we need to talk more about this. I think this is probably will be a suitable point to finish it, and then we can pick it up the next time here, because we also need to talk about harmonics and things like that as well, and so on and so on. So it'd be a bit easier if I just start this particular section from the beginning, and also I notice we're exactly halfway through the slides as well. So it'd be a good point to finish this tomorrow morning then. Yeah? No, physics, the extra class.